In this video, we're going to have a look at how sequences can be used to determine the results for investments. And we've got two types of investments that we're going to examine. One is a one-off investment, in other words, where we put some money into an account and leave it there for a period of time. And another one is where we have regular deposits. So this would involve putting money into an account on a routine basis, say every month or every 6 months, etc. And an example of this might be superannuation, where people put money aside for their retirement. It's recommended that you pause here and read this example prior to us going through and analysing the key components of this question. So now we'll highlight some of the key parts of the question. We can see that we've got $1,000 invested and the interest rate is at 5% per annum, and we're using compound interest, which, as you can see at the base of the question, is being done annually. And what we want to do is have a look at the amount in the account after 3 years. So doing a calculation after 1 year, we know that the money we get back will be, first of all, the money that we started with, and then we add the interest. Now the interest is 5%, and we can express that percentage as a decimal, in other words 0.05 of 1,000. So looking at these two parts, what we can do is factorise out the 1,000, and we're left in brackets with 1 plus 0.05, and that comes to $1,050. Now we're going to repeat the exact same calculation, but because we're using compound interest, we're going to increase it at 5% based on $1,050. And that means at the end of 2 years, the amount in the account is $1,102.50. Now, a simple way to repeat this calculation year after year is to say that if we're going to increase the amount in the account by 5%, what we do is we use what's in the bracket, which is 1 plus 0.05, and multiply that by the amount from the previous year. So putting that in sequence notation, that means that Tn, which is any particular amount, is equal to the previous year's amount multiplied by the figure in the bracket, which is 1 plus 0.05. And the reason why we're multiplying it by 1 plus 0.05 is because the 1 indicates the amount that we have, and the 0.05 is the 5% extra. Now, to repeat this recursive definition, we have to have a start value, and we can say here that T0, in other words the value of the account after 0 years, is 1,000. So using a calculator, we can go through and check this sequence term after term, and we see that after 3 years the amount in the account is $1,157.63. Now let's have a look at our next example, where what we're doing is investing some money, but there's also some regular payments going into the account each month. It's recommended that you pause here to read the question before we go through some of the key parts that we need to identify to solve the problem. So we can see here we're investing $2,000 at 4% per annum. And in this case, we're using compound interest, where we're doing the calculations monthly. And at the same time, we're adding an extra payment of $400. The question is, how much is going to be in the account after 2 years? Let's first of all look at the interest rate. Now the interest rate is 4% per annum, which means per year, but we're doing the calculations per month. So what we need to do is take into account that that 4% per annum needs to be divided by 12 to give us the percentage per month. So let's examine how we determine the amount in the account after 1 month. Now we know we start with $2,000, so let's say that the amount in the account is 2,000 times 1, in other words the original amount. And then what we do is we add the interest. Now the interest is determined by looking at a percentage of $2,000. In this case the percentage is 4 divided by 12 and then divided by 100. Now the reason why we do that is because the 4 is the percentage per annum, dividing by 12 creates the percentage per month, and dividing by 100 means that we look at it as a decimal. And then what we also do at the end of the month is that we add $400. So this is the calculation for month 1. But we can see here there's going to be some common parts to this expression as we go through each month. So let's have a look at the notation, but do it for any month. What would happen is that for any month n, the amount is based on the amount from the previous month. We would then add the interest for the amount from the previous month, and as beforehand, it's 4% divided by 12 to make it a monthly rate, and then divided by 100 to make it a decimal. and then we add $400 because each month has $400 added to the account. Now we can see that we can do some factorization. We can factorize out the amount for the previous month, which is month n-1, and you can see that in red. And if we take that out and put the remaining bits in a bracket, we have inside the bracket 1 plus 4 divided by 12 times 100, and then of course we add the 400 for the regular payment each month. Now we can put that expression in terms of a sequence equation, in this case a recursive definition. We know that the amount for any month n, in this case Tn, is equal to the previous month, which is Tn-1, and we multiply that by, in brackets, 1 plus 4 divided by 12 times 100, close the bracket, and then we add the $400 for each month. But of course with a recursive definition we have to have a start amount, and we know that T0 would be equal to $2,000. We can also express the same recursive definition, but this time we can say instead of being Tn equals, we can make it Tn plus 1. That would mean that the term on the right hand side of the equation becomes Tn. If we put this information into a calculator, we could find out the amount in the account after 2 years. Of course, we have to keep in mind that 2 years is actually 24 months. So because we're adding interest every month and also a payment every month, what we need to do is determine the value for T24, and that comes to $12,143.44.